In today's presentation, I'll be talking about aerodynamic parts in race cars. The Formula One race car has various aerodynamic pieces, and these can also be seen in airplanes and are directly linked to aerospace engineering. The main point of having all of these modifications to the race car is to take advantage of the aerospace concepts and get the fastest lap time. Some of the features and pieces include the front and rear wings, nose cones, side pods, and barge boards. Here are some pictures of Formula One race cars here, and then here we have two cars: a passenger car, which is a Mazda RX-7, and a Formula One race car on top. So the challenge in racing, the challenge is always finishing as fast as possible and getting the fastest lap time. Maintenance checks and pit stops do reduce the or cause increase in lap time, and that's a disadvantage. So reducing the drag force is a main factor to improve lap time, but another important factor is tire wear, and aerodynamics or aerospace concepts can be used to improve all of these and overall improve the lap time. In the 70s, engineers at Lotus started using airplane-inspired aerodynamic parts, and this is when they had a huge advantage and they would win races easily. Here we have the Lotus race car that first introduced the aerodynamic or aerospace parts in racing. So the first person to design the race car with like aerodynamics in mind was Camille Ganassi, which was a Belgian race car driver, and he was around in 1899, which is when he broke the 100 kilometers per hour barrier. Planes were invented shortly after, so those took priority. And after the wartime and all that was done, in the 70s was the birth of the aerodynamic airplane parts being used on cars. Engineers such as the Lotus engineer Colin Chapman was the first one to introduce aerodynamic parts into race cars. Many other engineers also did this, like Ferrari. And the 80s was the ground effect era. This is when we start to see race cars take advantage uh, of the features of aerospace to generate downforce and giving several advantages, such as faster turn speeds and less tire wear. Side pods were also introduced, and those also increase downforce, which has lots of advantages. Here we can see basically the evolution of the race car. Uh, at the beginning, they kind of just look like tubes or teardrops because those were the most aerodynamic shape. So this is who was involved. We have Colin Chapman, which was he played a huge role in this, and his company. He was the founder of Lotus, the racing company, and eventually a car manufacturer. And he made lots of innovations. The Ferrari race team was right behind him, and they made a lot of innovations as well. And obviously Camillo Ganassi, the race car driver, which made the original design. A lot of the parts on a race car nowadays are very similar to those that are in airplanes. The airfoils look almost exactly the same. They're just scaled down a bit. But in this case, they're used to generate downforce rather than lift, because downforce could be used to take advantage of other things. Uh, the airfoils are essential for racing, and nose cones are as well. They are one of the most prominent features on a plane, and they are also seen on race cars. So the ground effect and Bernoulli effect are mainly in play when talking about downforce and airfoils on a race car. Here we have some pictures of some of the aerospace stuff where CL is downforce. Here we have the acceleration, where as the downforce, as it increases, the acceleration on turning also increases. So on the industry of racing, it's made a huge difference who knows where it would have been without aerospace engineering. If they didn't exist, the main things that would racing would depend on would be the engine power and how well the driver could drive. So it gives racing another dimension, I'd say. In conclusion, aerospace applications are game changing in racing. Downforce is very essential in modern day racing if you want to get anywhere. And there's a lot more rules on a racing team. The end.